So proving identities has a lot to do with some things that you guys learned back in trig. Does anybody remember how to rewrite cosecant? Fine, great job. What about secant? Cosine, good job. How about cosine? Oh, good job, Katie. Yeah, we have two options, 1 over tan or over sine. Anybody know the tangent? Sine over cos. Good job. Perfect. Right. This stuff is going to be super important when you guys are proving your identities. Right. If you still don't know these, right, it's going to be kind of rough. Right. You got to make sure you know them. The other thing that's going to come up, you guys learned something called the Pythagorean identity, and there was one main one that if you knew that one, you could get the other two. Does anybody remember like the most important one? Yes, nice job, Katie. Sine squared theta plus cosine squared theta always equals 1. Very nice. Do you guys remember how we could get the other two, anybody? Oh, Katie, this is a little fresh in your head. Good job. Right. So imagine if you took this and you divided every single one by cosine. What would sine over cosine give you? Tan. So our next one's going to be tan squared. What about if you divide that by cosine squared? Well, 1 would reduce to 1. Now what about if you divide that by cosine squared? What is 1 over cosine? Secant. Good. It's going to be secant squared. Great. Okay. So that's going to be my second identity. Katie said we would divide by, yep, now we're going to divide them all by sine. So imagine you divided this by sine squared. What would you get? 1. Yep. What about this one by sine squared? Good job. Cosine squared. And the 1 by sine squared. Yeah, good job. Very nice. So these are going to be your 3 identities.
Oh, that's not hard.
Yeah.
As long as you remember.
Yep, as long as you remember the first one and you know like this stuff, you can find the other 2. Remember, the one that comes up the most is this one. Right? They always have something somewhere in your Regents exam where sine squared theta plus cosine squared theta always equals 1. All right, so all this stuff we're going to be on the lookout for down below. Now, to prove that something is identity, here's your goal. Basically, what you're trying to do is get both sides to be the same thing, but you could only touch one side. So when we go about this, we want to look at kind of which side you guys think has more stuff going on.
On the left.
Probably the left. So we want to pick a side to start with, and what we're going to do is look for ways to change and simplify the trig functions by writing them in terms of sine and cosine. So we want to use all of these properties up here and how we rewrote things in terms of sine and cosine. That's what we want to do to kind of hope that things might cancel out and we can reduce them.
So tan would be
Exactly, Frida. Good. So if we go through this, right, you want to break down every single part that can be rewritten. So I like that. Tan, you said was sine over cosine. Great. What operation is going on with all this stuff? Multiplication. Good. Can you do anything with sine x? No, let's just sine x. And you want to put it over 1 because, right, same thing with the cos x. You can't really do anything there. But what we want to do is we want it to equal sine squared x. So let's look in here. How can we do? Good. Cosine and cosine can cancel. Remember, you guys can cancel multiplication if one thing's on the top and one's on the bottom. Perfect. Yeah, sine times sine is sine squared. So this is sine squared x equals, we have it over here, sine squared x. Boom, we're done. Perfect. That's it. Now, they're not all this easy, but I've only seen this concept once on the Regents exam, and the one time it did show up, it was super easy like this. Like, really easy.
Like, did you ever incorporate that into, like, any other?
Not really. Like, you guys have done little, like, parts of this, like, where it was not an equal sign and asked you to prove it, where you guys did, like, division of these and multiplication. It's kind of the same idea. But just when you guys prove something's an identity, really make sure that you're only touching one side. This side you can't ever change. Okay. Other things you might want to look for if we just can't do it by changing things. you might need to factor or use one of the identities that are up here. Let's see about this one. Okay, so what side do you guys think we should start with?
The left.
Probably the left. That's got way more stuff going on. Okay, so we have a couple ways you guys can do this. And this is something where maybe like Alex thinks of one thing to do, Jameson wants to start another way. They can both be totally right. It's just how your brain kind of like decides to do the order here. Yeah, oh yeah, that's right. That's good. What do you guys, anybody have an idea where you want to start with this? Okay, you want to put side over one, all right. Okay, so you want to switch everything. Is that what you were saying? Like this thing? Okay, sounds good. Let's do it. Okay, so let's rewrite it. So you said this is going to become sine over 1. That works for you. And then you wanted to change this one to 1 over sine. And then minus sine over 1. Careful, we can't cross them out because vibrations are yeah. A little tricky. Okay. Well, what do you guys usually do when you see something that's on the outside of a parenthesis? Distribute. Yeah, it's good. Distribute it through. So let's take this and bring it through. And remember, we can only touch this left side. We can't do anything on the right side here. Let's see what's going to happen. And again, if you want to write it out, some of you guys could probably do more steps in your head than others. So when you guys multiply here, we're going to get, make sure you do top, top, bottom, bottom. This becomes sine over sine. Yeah. Good job. Now this time, sine times sine is going to give me, good job, right, over 1. Okay. All right. Now keep in mind we want this thing to equal cosine squared. All right. Do you see anything that can be reduced? Sine over sine. Good, Lauren. Sine over sine, I like that. So we have right now 1 minus sine squared. Okay, we want to show that this equals cosine squared. Yes, very nice. Yes. And we haven't seen this come up in a while. Anytime we see a 1 being added, subtracted to a trig function squared, we want to decide, did this come from maybe one of our identities up there? Well, right, well, careful, we can't cross the equal sign. We only work with one side. Which of your identities uses a 1 and a sine squared? Top one, yeah, and this is the one that you guys will probably see. So if we look at what, we know that sine squared theta plus cos squared theta equals 1. We want it to look like 1 minus sine squared. So what would you guys have to do to have 1 and then a minus sine squared on this side? Good, Frida. If we subtract sine squared, now what we get is cos squared equals 1 minus sine squared.
Do we have to show that?
I would show this. Yep. And then over here you would say, well, you just proved it over there. So this is cos squared equals cos squared. Good. Now, like Carly, you were saying you want to add sine squared over there.
Yeah.
Technically, that, I mean, the idea that would make sense, but you can't touch anything on the side, so you can't like even move things over there. Because that's a technique of like proving the identity. No.
Doesn't make any sense.
So then if you can't do that without crossing the equal sign, then you just do a separate work from an identity to show that they're the same thing.
Yep.
So
Yeah, you want to
you
show.
can't cross the equal sign, but you can do two separate things at work.
Yeah, well this is like, okay, well, this doesn't really, okay, let's say I'm grading this and I have no idea about math. How would I know that like, because here's the idea behind these, okay? You're trying to get these both equal, right? So what's stopping someone from just saying, all right, well I know it's got to equal cosine squared, so I'm just going to put cosine squared over here. You know what I mean? But otherwise, like I wouldn't know that you knew that this was the identity. Your goal is just to get an equal. You could just like cosine squared equals cosine squared. Like how would they know that you actually knew what it was? That's kind of like the reason why you want to show more things, so that they really let you know that you knew it.
So since on that side we just flipped it, if you did a different one, it equals it,
Like
I get to show you work, but I just don't get how
you would show it.
no, I how we would equal prove that. I guess.
This is so stupid, no offense.
Well, do you guys see what I'm saying is with this part? Like, if your goal is to get an equal, like, I can't just write cos squared equals cos squared. Because how do you know?
Showing your work is like up here, and this one was like, you combine these, and then you got it, and then it equals it, but then down here, it just comes out of nowhere.
Okay, it kind of, you're right, it kind of does come out of nowhere. It's because of using an identity, you have to know that this is cosine squared.
So that means, okay.
That means the same thing. Like, the work that I showed over here was just to show you guys that this does equal cosine. It's kind of like, yeah, it's kind of like a substitution, right? You just want to make sure that your reader knows that you actually know why 1 minus sine squared is cosine squared. It's just because of this. And you could, like, this is just like extra work. Right? It's not, this is not part of the equation. It's kind of like what you were saying, Andrew, like showing why you could substitute in something. That if you guys minus sine squared over, you get cos squared equals 1 minus sine squared. So this is kind of what you wanted to show, that, you know, these two things are equal. So then, 1 minus sine squared is cosine squared.
So I thought that was like the equation that we figured out, but now I see that like 1 minus sine squared actually is cosine.
Yeah, it means like the same thing. And
so wait, cosine squared is like exactly the same as 1 minus sine squared.
Yep.
You just gotta prove it.
Right, you're just proving it, exactly.
Wait, so does that mean 1 minus cosine squared?
Yes. Yes, Frida, exactly. Frida just said another good thing. If you guys had 1 minus cosine squared, what do you think that equals? Sine squared.
1 plus cosine squared?
Well, you would never actually have a 1 plus, because to move either of these over, it has to be subtraction. This one. Good question. But that's like what you guys are going to be on the lookout for, things like that.
It's like a fact. It's like if you're like 10 equals 6 plus 4, you know, 10 minus 6 is what? 4.
Right. Yeah. No, that's perfect, Julia. You're right. It's like, it is. It's basic. It's a bunch of like facts, and you can only move them certain ways to make it make sense.
You can't add this to 10 to 4.
Yep. I love it, Julia. That's a good way to think of it. All right, let's try this one. Okay. Oh wait, is this different than what I did you guys?
No.
Oh, yes. Okay, never mind. All right, sorry. All right, so what side do you guys want to start with here?
Well, can we make the tan the sine over the sine?
Wait, you can only change one side though.
Really? You can't just fix them.
Nope, you can't touch that one side, you can't do anything.
They're split half.
Well, left side, yeah, I think that's a good one. So let's see, over here, what do you guys want to do first? 1 over cos sounds good, Dean. Let's try it.
1 over cos
Squared, yep. And then we have 1 minus cos. No, that's fine. Then they won't take points off for that. It's like you change the variable. Alright, let's distribute. Sounds good. And we bring this base row. We get 1 over squared minus, what's the next fraction look like? Squared, yep. I'm going to show you another way to do this. And there are like probably 3 or 4 different ways you guys could have started this to show it. So just because we're doing it one way, maybe you're just thinking something else, or you saw something else in here and you're doing it another way, it's probably still okay. There's a lot of ways to do these. Alright, what are you guys thinking next? Okay. Yeah. I like that you guys are giving me this info. Alright, so let's keep going here. 1. Okay, so now what the heck are we going to do? Is that going to help you? Maybe. Let's try it. Yeah, because the second. Ooh, so it's an identity. Okay, great. So 1 minus cosine squared, you want to turn this back into this? Now someone else could be thinking, I thought about a whole different way to do this. which is different than this one, which is fine, right? We're going to prove it though, like what you guys are thinking. So, all right, well, let's see. Let's go back to our identities. Because we have secant, we got something being squared with a 1. That's kind of our clue. Oh my gosh, let's go back there and see. Ooh, here's one. It's got a 1, a tan, and a secant squared. Yeah, good. We're doing a little proof. I like what you just said, the proof of work. All right. Frida, what was your identity? What did you say? Great job. Okay, so if we want secant squared theta minus 1 equals tan, we have to move that good 1 over. So this is going to show us tan squared theta equals secant squared theta minus 1. Yep, so tan squared theta equals tan squared theta. Boom, we're done. Now, I'm very curious, did anybody, because you could have done this in one step if you saw something else. This worked. We did it. I love it. Did anybody do it a different way?
No. You
did? No? Nobody? Yeah, I'm going to show you another way to do it. Yeah. No? Okay, you're all just taking my word for it. But, I mean, this was good because I like that you guys gave me the steps. This is kind of what you would have thought too. So, that's good. You see both ways. Alright, so I want to show you another way you could have done this from this step right here. No, sorry.
In the beginning, is it better to just distribute it and then make it smaller?
Doesn't matter. Doesn't matter.
Oh,
Andrew, did you see it?
Yeah, because of the identity, you can say 1 minus cosine equals secant, and secant over cosine equals tan.
Wait, you're really close to this.
With the
Doesn't
identity,
equal
like,
sequence. You can't.
sine.
Sine squared, good. Do you guys recognize this? Remember what you just said? 1 minus cosine squared is always sine squared. So this whole thing is really sine squared theta. Now, if you have that and you're timing it by 1 over cos squared, so you get sine squared theta over squared theta, which is tan squared theta, right? So it's the same thing. Oh, I like what did both ways work?
Yeah.
Yeah. Someone I'm sure can even think of another way. Yeah, Lauren.
For the 1 minus cos squared theta, would you have to show your work for the sine squared
You
theta?
should. You should. So, more important, like this part's not as important up here because it's more the ending one. It's like the last one, just because your goal is to get them equal, so there's nothing stopping you from putting them the same, even if you didn't know what the heck you were doing. You know, up here you kind of had to at least know something about it. Good job so far. See if you guys can try this one. I gotta get a new drink. I ended up both. I always throw it all over. That's even better than the whole flip. Alright, here, lots of good things. What do you guys kind of start with here? Like a foil, yeah. And you could do the whole foil if you want, but what are these of each other? They're conjugates, right? They look exactly the same except the middle sign is different. So if you want to, you can just do first thing there.
Oh wait, well then that's already it then.
Oh my gosh. Carly, I think you got it, lady. Anybody want to put it up there?
No.
Anybody want to put that one up for me?
I can do that before you.
Good question. How would you not like
Alright, example 5. What's that number 5?
But I just like, if you get that one, and do the radius or yeah, because they literally have to make a bowl, and then they just scoop it in the bowl. Workers. Oh, okay. I said they scooped it out, and then I was like, I kept asking who they were, and she was just like, they like it.
Well, like what we're gonna do next chapter.
What?
Next chapter, we're gonna do oh, you need to shower.
Yeah, I have a lot of questions.
You should.
Do we actually do it for
I mean, on your regions, it would show like where you knew it was from.
Alright, I don't know.
Okay, so what identity think you use? What does that look like? It's when I find the first data. It's hopefully the same thing. Thanks, Julia. That was great. Yeah.
So wait, if you look at all the ones on the top of the list.
Like the first set of them. You left me?
Perfect, Frida. You did it. Yes, good job. All right, this looks great. All right, this next one's a little tricky. These are tricky. Frida, that was good. If you think if you got them, feel free to keep trying them. The more you guys can do on your own is probably better. So what side do you think you want to work with here? The right side? Okay, well if you try to do something on the right side, this is good as, I'm just going with what you guys said. Can you change anything over here?
No.
Is there any operations you can do more of? Not really. You get
The
stuck.
left side is one.
Left side you kind of. Right is right. Yep. Good job. I'm going to do X's if that's okay, just because it's a lot easier to write with data.
How do you know which side you should start on?
Well, kind of what we did here. This one, you can actually do something. Like you can write it out twice. If you tried this, can you rewrite a sine or cosine? And like those aren't like terms, so we can't really get like stuck. It's not wrong. If you guys try one side, it doesn't work, stop and try the other one. Not a big deal. Alright, what do you guys think you should be doing on the left? We're going to add them, FOIL them. FOILs, yeah. And this time we have to do the whole FOIL because these are not conjugates of each other. So you have to do the entire FOIL out.
So wait, then, if I'm only allowed to work on one side, then I could just say, then this is just one, right? Because then we want to one side is one. Okay, that was just a hard one.
No, well, I don't know. I don't know how you guys are going to do it. Okay, so we got sine squared x. Then you guys do your outer. How would we write that? Make sure it's not fractions you're multiplying, it's like sine times cosine. Good, sine x, cosine x. Good job. Same thing in the middle. You got cos x times sine x. Yeah, cos x sine x. Or could you make it sine x cos x? Yeah, because it's commutative, right? So I'm going to make it sine x cos x just so it's like the other one.
So then it would be.
Yes. Good. Keep going with this idea. And then let's see, we get plus cos squared at the end. Now, Aaron, you said something about this. What could you make that?
2 sine.
Awesome, right? They're like terms. Sounds good. Okay, so we still have a couple other things going on. We got a sine squared theta, and we got a cosine squared theta. Oh my gosh, who said that? Miranda? Oh, so good. Okay, it's coming up over and over again. Sine squared theta plus cosine squared theta is just 1. It's from our identity. So we have a 1, and we have 2 plus 2 sine x cos x. Is that what we wanted? Oh yeah, perfect. It worked.
Oh my god. How was magic?
Because you want it to equal the other side. So whatever, you always want like them to be the same. Good job. Alright, let's see if you guys can try this one. See if you can figure out where you want to start. This is a hard one, I think, with the starting.
Which side did you start on?
They're the same thing. Oh, I got the
I got you.
Which side did you start on?
I'm going to start on the left side.
I tried the left side and didn't see anything on
So, let's see. I hope I didn't mess this up when I copied it down.
Did you have to get like a common denominator to add them?
Alright, so you know what? I love it. Because if you're adding fractions, we do need a common denominator, so let's try it. So what do you want to multiply this one by? Sine squared. Good. This one's going to need a cos squared. Okay. Alright, so let's multiply the top. So we have sine squared times 1.
Oh, that's 1.
No, you guys are catching on here. Okay. Good luck. Now on this side we got a cos squared theta over sine squared theta cos squared theta. Okay. Alright, so we have a common denominator, which is awesome. What could you guys do with the tops now? And we don't
add them or make it
add them. Good. You can add the tops now. Right. If it helps you to write more steps, if you guys, would it help you to see that you would have like what it really looks like? There, sorry. Is this? I mean, some of you guys who could do this in one step feel great. If you don't, you know. So now, what is this? This is just 1. Okay. Well,
Well, that'd be 1 over sine squared cos, which is
yes, Carly, fantastic. You got it. Okay. Because is it 1 over sine squared? Cosecant squared? 1 over cosine squared is secant squared. And that's like what you guys wanted. Way back at the top. So, Andrew, you were like, something with the 1 had to happen. That was good. Good job. Alright, you guys did awesome today. Here's your homework.
Is it on textbook?
Yeah, sorry.
No.
When I give you guys good things, like the Regents questions on this, there's only been 1, so I don't have like a good JMath one to give you guys. So the book one's actually better. I kind of just go off of wherever I can find the best stuff for you. 3 to 17. Please just do the first column. Okay. 488. Sorry. If you want to take a picture of it, there are some books in the back. I'll come around if you guys want to. Oh, sorry.